Hello, and welcome to this presentation of a study for the manipulation of an industrial harness. This research is being financed by Horizon 2020 or model projects. The manipulation of an harness is a complex task involving the formable objects, and its application in industrial fields still rely on human workers. In our research, we study how to tackle this problem by means of an autonomous system. To do so, firstly, we introduce a topological description of an harness using graph theory, where the harness is represented as a directed graph in which each branch and endpoint is represented as a node, while the segments are represented as edges of this graph. Using the same concept, we developed the perception pipeline, that starting from a 3D point cloud, it creates a binary 2D image, and after that a graph representing the harness in the scene. The algorithm is derived from FastDLO, accepted at the Robotic and Automation Letter and presented at IROS 2020. From the graph structure, we obtain a list of key points divided in endpoint, branches, and intersection. As for the manipulation task, we study the problem of arranging the harness on a flat surface with no intersection point. For a given intersection, we can use the branch from which the segments are originated as a center of rotation, and then rotate the segment on top to solve the intersection. The release point is selected as the output of the cost function maps. We consider placing the segment inside the field of view of the camera, but as far as possible from other harnesses and from the grasping point. This idea of score can also be used in future learning approaches. The method works also if the segment doesn't have a common branch. In fact, as is shown in the example, we can recursively pass the graph and look for a common branch, exploiting the graph structure. Once the common branch is founded, we can then rotate the cable using the designed approach. Here is an example of the manipulation. As you can see, the rotating branch can be at first approximated semi-rigidly in case of slow movements. The gripper is also slightly rotated. The approach seems promising, however, we are now investigating the problem of robustness. We are working on using graph neural network for a better detection of the key point. Instead, for the manipulation, a learning approach can be used to approximate the deformation originated from the motion and improve the manipulation that instead, in this case, it was supposed rigid. Finally, we are also integrating the use of a solver that gives the order on intersection to be moved to get fully arranged harness on the surface. With that, I have concluded, so thank you all for the attention.